So let's do the integral of 1 over sine of x plus sine of 2x. We need to find a way to deal with the sine functions with different angles in the integrand. It's not a sum of two sine functions with different angles in the numerator, and rather, the sum is in the denominator, so we can't just do the integrals separately. And it's also not a product of two sine functions with different angles, because if it were, we could use the product to sum identity. What we need to do instead is apply the double angle identity on the sine of 2x term. So we can rewrite this as the integral of 1 over sine of x plus 2 sine x cosine of x instead of the sine of 2x. And each term in the denominator has a sine x term, so we might as well just factor out a sine of x. So the denominator would become sine of x times 1 plus 2 cosine of x. We would ideally like to substitute u equals cosine of x, but to do that, we would need a single factor of negative sine of x in the numerator, and we would also need to write the rest of the integrand in terms of cosine x only. So here's what we're going to do. I'm going to take out a constant of negative 1 outside the integral, and I'm also going to multiply both the numerator and denominator of the integrand by sine of x. So this becomes negative integral of negative sine of x over sine squared of x times parentheses 1 plus 2 cosine of x dx. We also need to rewrite the rest of the integrand in terms of cosine x only, and we can do this by rewriting sine squared of x as 1 minus cosine squared of x. So we can rewrite this as negative integral of negative sine of x over 1 minus cosine squared of x times 1 plus 2 cosine of x dx. So we're actually ready to do the substitution now. If we let u equal cosine of x, then du equals negative sine of x dx. And if we substitute this into the expression, we get negative integral of 1 over 1 minus u squared times 1 plus 2u du, since the negative sine of x dx is replaced by the du, and 1 minus cosine squared of x becomes 1 minus u squared, and 1 plus 2 cosine x becomes 1 plus 2u. So let's think about what 1 minus u squared equals for a moment. We can rewrite 1 minus u squared as negative parentheses u squared minus 1, and we can also factor u squared minus 1 as u plus 1 times u minus 1, so the entire expression is just equal to negative u plus 1 times u minus 1. So we can just rewrite the entire expression as negative integral of 1 over negative u plus 1 times u minus 1. And for the 1 plus 2u, I just want to write it as 2u plus 1. And we also have the du at the end. We can actually bring the constant of negative 1 outside the integral back into the integrand. And that negative and the negative in the denominator will cancel out. So we end up with the integral of 1 over u plus 1 times u minus 1 times 2u plus 1 du. Yes, we have three distinct linear factors in the denominator, which means we need to use partial fractions with three factors. Oh, this is going to be fun. So here's how we do the partial fractions. We start with the expression 1 over u plus 1 times u minus 1 times 2u plus 1 and set that to equal a over u plus 1 plus b over u minus 1 plus c over 2u plus 1, because this is how we do the partial fractions when we have distinct linear factors in the denominator. If we multiply both sides of this equation by u plus 1 times u minus 1 times 2u plus 1, we end up with the equation a times u minus 1 times 2u plus 1 plus b times u plus 1 times 2u plus 1 plus c times u plus 1 times u minus 1 equals 1. If we plug in u equals 1 to this equation, we end up with 6b equals 1, which means b equals 1 over 6. If we plug in u equals negative 1, we get 2a equals 1, which means a equals 1 half. And if we plug in u equals negative 1 half, we get negative 3 over 4c equals 1, which means c equals negative 4 over 3. If we plug in these solved values for a, b, and c, we end up with 1 over u plus 1 times u minus 1 times 2u plus 1 being equivalent to the expression 1 over 2 times parentheses u plus 1 plus 1 over 6 times parentheses u minus 1 minus 4 over 3 times parentheses 2u plus 1. So we can rewrite the integrand as 1 over 2 times u plus 1 plus 1 over 6 times u minus 1 minus 4 over 3 times 2u plus 1. If we integrate each fraction separately, the integral of 1 over 2 times u plus 1 is 1/2 times ln of the absolute value of u plus 1, and the integral of 1 over 6 times u minus 1 is 1 over 6 times ln of the absolute value of u minus 1, and the integral of the third fraction is negative 2 over 3 times ln of the absolute value of 2u plus 1, and we need to add the constant of integration c. So we originally substituted u equals cosine of x. So if we substitute that back in for the u, we end up with 1/2 ln of the absolute value of cosine of x plus 1 plus 1 over 6 ln of the absolute value of cosine x minus 1 minus 2 over 3 times ln of the absolute value of 2 cosine x plus 1 plus c. It's a pretty big expression. I guess that's just what happens when we have both a sine x term and a sine of 2x term in the denominator.